Hi, my name is Michael Moreno. I'm working with Chris Farnetti, Jason Hurst, and Wesley Donahoe on this project. We are working to design an effective thermal mug that will cool a warm beverage. Our target customers are construction workers and beer drinkers, both of whom need drinks cooled quickly and are receiving warm drinks. In this project, we are using experimental design and scientific method. We are using them because it helps us reach success and helps us reach our goals. We will benefit from experimental design and scientific method because it allows us to verify our understanding of a subject, it helps us explain our work to others, and it helps us prove the credibility of our data. In the experimental design process, you start by asking the question why. Why are you doing the experiment and what are your goals? Once you understand your goals, you can then move on to knowledge construction and take advantage of the current knowledge out there on the subject. Once you have the knowledge, you can form a hypothesis, build a plan to check the hypothesis, perform an experiment, and if your data doesn't quite meet what you're looking for, you then repeat. In preparing for our experiments, we had to build an Arduino circuit and an Arduino program that would output temperature as a function of time. We did this by using the print command, which would display the data recorded in a debug window. This could later be copied into an Excel sheet and analyzed. In our first experiment, we melted ice in water. The goal was to find out when ice and water would reach equilibrium temperature based on the mass of the ice and the mass of the water. Unfortunately, no resources were available at the time to make this an adiabatic system, so the results are slightly skewed. Nevertheless, the results of the experiment were close to what we had expected. The water started at room temperature. It instantly dropped once the ice was put in until the ice melted and the water reached an equilibrium temperature. Once that happened, the water slowly began to rise back up to room temperature until it reached it. For our second experiment, to further verify the integrity of our math model, we took a Coca-Cola glass and froze it in the freezer. Once it was frozen, it was then removed and filled with room temperature water and allowed to reach equilibrium while data was being recorded. As you can see from the data, the temperature starts at room temperature and slowly moves downwards as the glass and water come into equilibrium. However, this does not work as effectively as the ice cubes worked, as shown in the first experiment. Seen here is our Arduino setup. As you can see, we used an LCD display to track temperature. Although this wasn't used for the actual data we received because it was taken off of the debug window, it was very useful in determining that the temperature sensors were working right when we were first experimenting with the code. For this project, we had to waterproof our temperature sensor so we could stick it in a glass of water. We did this by using a straw which was hot glued at one end. That end was then folded over and stapled so it wouldn't unfold. It worked rather well. It was positively buoyant, so we went ahead and slid the temperature sensor into it, and it recorded temperature fairly accurately. In our recommended design, you could take a standard thermal mug and insert liquid in between the walls, which could then be frozen to cool the beverage. The exterior wall of the cup would be made up of a compound that is less thermally conductive than the typical metal, to keep heat from entering the system. Lastly, the interior of the cup would have increased surface area due to a bumper spiral design to dissipate the heat faster. As stated previously, the math model we designed could not take into account all of the improvements we did to the thermal mug. However, we did continue to run it, using the thermal compound between the walls at a below freezing temperature with a beverage of approximately 77 degrees Fahrenheit being added. The results were that it would cool the beverage down to approximately 40 degrees Fahrenheit. We had some great team strengths. One of those is knowledge diversity, which allowed us to build on each other's knowledge of programming, circuitry, and fabrication to build the best experiment possible. We were also able to multitask really well and have different people working on different parts to get it done quickly. Nevertheless, we still had a shared goal which was understood by all, making the experiment a complete success. There were still some things we could improve on as a team. We all have varying schedules with college and work. It's very hard for us to get together and meet as a team, and that would have been nice. We also could have assigned portions of the project earlier to get things done earlier and made sure it all worked out nicely. Also, having one person responsible for everything and just checking sure everything is done would be nice. We learned several great things on this project about experimental design, the first being that a simple experiment can still yield great results. Also, a simple experiment takes a lot less time, and time is valuable. Also, the more data you collect, the better, because reproducing the experiment takes time and materials, neither of which are always available.